The agenda is we're going to start by a short introduction. Then I'm going to state the talk objectives. Then we're going to move into modeling the system. What system are you going to load test and diagnose? Then we'll talk briefly about load characterization. What types of load can you apply on a given system? And then we'll move into the core of the talk, which will be the measuring, monitoring, profiling tools, techniques, and all that stuff. And we'll close with a Q&A session. We do have quite a bit of material to get through, so I would appreciate it if you hold your questions for the end, or just come find me after the talk and we can talk about it, no problem. About me, I'm a solution engineer at Alfresco for about 4 years now. I've been involved over time mainly in pre-sales and consulting. I am based in Paris, France. My Twitter hashtag is @Romain, so please do tweet how awesome this presentation is. And then my email is first last name alfresco.com. Just before we go into deeper, I just want to know, can you raise your hand if you've ever had a performance problem to diagnose? Cool. And keep your hand up if it was hard. All right. So I hope this presentation will help you. The objectives of the talk is that you guys can have a better understanding of the whole system and all the components that interact with it, and then with this have a better focus and a better tool choice so that you can focus directly on the problem and not go after a wild goose chase or whatever. And this will hopefully result in less frustration and a better and decreased time to identifying the problem. So let's start by just modeling the system in a kind of abstract way. So just a basic definition about resource consumption. Basically, you have client activities, client demands that create demand for system resources, that are the hardware and the software, whatever. And that results in response times that are either within or exceeding stated tolerances, or hopefully within. So just before we start, basic example of a sample architecture that you could have for an Alfresco project. I'm going to state that this presentation is not necessarily specifically about Alfresco, but this is just an example to be introducing concepts later. So you could have a client tier with different clients interacting with the application. You probably have load balancing in front of it all, with most commonly Apache HTTPD, but it could be HA proxy or you name it. Then you'll probably have several instances of share if you're in a cluster that themselves would be clustered maybe with Hazelcast. In the middle, you would have maybe also load balancing between share and the repository, which would also be distributed. And then maybe you can have indexing as well, and load balancing between the repo and the indexing tier. And then, of course, at the end, you go to the storage, whether it's the DB or whether it's the content store that might be stored over NFS or a fiber channel on the SAN, for example, most typically. And those components, if we look at it from a physical standpoint, obviously you have hardware for the clients, hardware for the load balancing, hardware for the web tier, hardware for the repository, the SAN maybe for the storage, indexing, all that stuff. So basically, we have all sorts of architecture components. We have hardware, we have disk drive of different type, different technology, different brand, different settings, all that stuff. We have memory, of course, which is basically on the same thing. You have a different amount of memory, different types of memory, different bandwidths, new generation, all that stuff. CPUs that are also rapidly evolving in number of cores, number of caching, level 1, level 2, level 3, multi-threading, all that stuff. You obviously have network going on between all those components. That network has a specific bandwidth and specific latency. And for the storage part, you can have a RAID controller, you can have dedicated hardware, you can have a replicated disk or whatever. And on the software side, you have obviously the OS, the JVM, the applications, and of course also all the external systems that the architecture that we presented will interact with, namely the database, the index server, the storage tier, whatever. And those hardware resources have obviously limitations. Otherwise, it would be a very different world. So it's basically static resources. They have finite capacity, so that creates serialization. If you exceed that capacity, queues, for example, in the disk drives, for example. And obviously, that means that there is a finite throughput that you have to deal with. Either you can work with the infrastructure that you were given and improve it, or add some of it. But you have to be careful when you add some hardware, because you have to make sure that the hardware that you target is actually addressing the performance problem that you have. For example, if you're not running out of memory, adding 64 gigabytes of memory is not really going to help. So you bought it for nothing. So that's the topic of the next section of the talk, which is basically how do you characterize the load that you're going to apply on the system that we've just described. So the main thing is there are, I think, three main types of testing. It could be load test. Then you would be testing the system. Does it conform to the load that I anticipate on my system? It could be a stress test. That means I'm going to go above the load that I imagine for the system and see what happens. Does the system go down? Does it still cope in a degraded mode, etc.? Or it could be also endurance testing, meaning, all right, the system is working fine for 1 hour, but what happens if I let it run for 1 week and see if there is any issues that come from that? So with these types of testing, you want a test plan, and you want your test plan to be as realistic as possible, meaning you don't want to have constant think times. You want different user groups that have different usages patterns, maybe some parameterization, meaning some randomization of the testing, not always the same thing. You also want definitely to have a decent ramp up and ramp down, because obviously if you launch 1,000 users at T0, that's not realistic because it's not going to happen in production. So you want also a test duration that is realistic compared to what we were saying earlier. You want to be able to sequence all the actions and the pauses in the test to be realistic. And for example, there is a classic bug in JMeter, which was fixed since, but now you could have, for example, say, do this and wait 2 seconds, do that and wait 2 seconds, do that and wait 2 seconds. And sometimes, depending on how you configure the test, actually what it will do is do this, do this, do this, wait 2 seconds, wait 2 seconds, wait 2 seconds, which is obviously not the same behavior that you want. So in some versions of JMeter, you want to have test actions that wrap the pauses. Whichever tool is used anyway, you want to get stats. You want to get more than just the average. The average doesn't mean anything. You want the percentile, 95, 99s. You want some variance. You want some variance to mean, standard deviation. And if you are a stat geek, you want to go into the index of dispersion, all that stuff. I do recommend that you stick around for the next presentation, which is going to be done by Derek and Michael, which is going to present how we benchmark Alfresco internally. And they are going to talk about this in much more detail. So I recommend that you follow this one by this other. So when you run the test, what's going to happen? You're going to have fake or real end users that make application requests. Those requests will be translated by the system into sets of local instructions to be executed. And of course, calls to external system could be the DB, could be the storage, could be the load balancer, and something else. The JVM will do the translation between those application instructions and actually machine code. That's one of the main roles of the JVM, along with memory management. We'll talk about that a little bit later with the different generations of the JVM. And the OS, what it's going to be doing, very schematically, is going to be doing allocation threading, thread scheduling, all the stuff that happens in the kernel, memory allocation, provisioning, depending on what memory allocator you are using, doing the disk I/O, network I/O, all that stuff, and all these system calls that might be get the time of day or anything that happens to be calling into the kernel. And the OS itself is going to invoke the hardware with the predefined limitation that we talked about earlier. So that's basically the chain of events that will happen when you launch the test. And when you consider all of this, my thought is that you need navigation. You can't just go about and look at the code and try to figure out what the problem is. So you need to consider all of this, the architecture, the hardware, the OS, the JVM, the users, the test plan, and all that stuff means that you need to have a performance workflow so that you don't have to look at the code to know what the problem is. You need to focus on exactly the right component to know exactly what the problem is. And this is what I would call the dominating consumer, meaning identifying what currently is the main issue, blocking your tests from performing better. This is what we are going to do in the rest of the presentation. And hopefully that will result in less frustration and a decreased time to identification of the problem. We move now into the core of the presentation, which is going to be the section about how we can measure, how we can monitor, what tools to use in what situation, and basically the workflow that we just mentioned. So this is, does it show well? Okay. So that's basically what I would call the main decision tree that you can use to identify all sorts of performance problems when you are running a load test against a Java application, not specifically Alfresco. The yellow boxes are the decision criteria that I'm regularly using to determine where to look at and what to do. The bubbles are the problem areas where a problem could happen. The purple one is when there's something wrong with the threading, the system is not used enough, and though you have a performance problem, so we'll talk about that a bit later. The pale blue one is the JVM. Is there a memory leak? Is there a problem with allocation? Is there a problem with sizing, configuration, all that stuff? The green one is the application itself. Is there a problem with the algorithm or whatever? And the purple one, the pink one, is the kernel-related machine problem. And this is what we are going to start with. So, for example, in the beginning, you want to use a tool that will tell you if the system CPU is above 10%, or if you have user and system about the same time, then you want to look at the kernel first, all the machine interactions. For that, you're going to need system monitoring. In this case, the dominating consumer would be I/O or network or locking. Oops, sorry. All right. And you would determine that most likely using either VMstat or MPstat. Has anyone here either used MPstat or VMstat regularly? Raise your hand if you do. All right. Cool. So this is basically a sample output of VMstat. You can run it, and it will tell you, for example, every second those lines of digits, which is it tells you a lot in one command, and that's very useful. The R column is going to be telling you how many runnable processes you have at the same time, and the B is blocked. So it means that if you have a consistent number in B, then something is preventing your processes from actually consuming resources in the CPU. The memory part will tell you if there is swap going on. That is a very important issue that we have quite regularly. People don't configure the system regularly in accordance to what is configured in the JVM, according to the amount of RAM that they have, which results in them having swapping immediately at the start of the JVM. So that's definitely something you want to look at. If you're on a Linux system, the kernel variable you want to look at is vm.swappiness. The default value on Red Hat in Debian is 60, meaning that once you've reached 40% of RAM usage, the kernel will allow itself to start swapping, which is definitely something that you do not want, especially with the JVM. So I highly recommend that you go on your Linux machine and change it to a G5 or 10, meaning don't swap anything unless you have 90% or 100% memory usage. And you can configure it in /etc/sysctl.conf on Linux if you want it to be persistent across reboots. So that's the swap part. The I/O part will tell you how much I/O is going on at the exact moment when you run VMstat. The interrupts is the number of kernel interrupts. You might want to look at. If you have too many, it means that the kernel is actually overloaded for some reason. CS is a bit of the same idea. It's context switch. So it means how many times during that period of time has a thread been ejected from the CPU because of something else was required. So this, if you have a very high number, it means that the CPU is completely overloaded with requests, and this is something that you want to look at. And the last part is actually very interesting. It's the CPU part split between user time, US, system time, idle, waiting time, and ST is still. It depends on the implementation, but sometimes if you are running a hypervisor and VMs, it can tell you how much time was actually stolen from that CPU to give it to another VM because the VM system was overloaded. So that could be quite interesting to look at if, obviously, the VM system does support it. So the main columns that you want to look at in that section is the US and SY, meaning if you have, for example, an SY that is quite high, above 10%, then that means that something's wrong either with I/O or network or threading. Something's going on in the kernel. And this is what we are going to see next. So that's what, as I said, if you have a high system time or if system time is about the same user time, you want to look at anything that's going on in the kernel. So it could be, if you want to look at the I/O, you can use I/O start, for example, or NFS I/O start if your I/O is on an NFS share. You can deduce that a bit from VMstat, as we just mentioned. If it's network, you might not use netstat or nextstat on Solaris. If you want to go deeper, but that's a heavier overhead, you can use dtrace or strace or all profile, and it will tell you in a very detailed manner exactly what is using the kernel, but down to the actual method of C or C++ code that is going on, and you can kind of deduce what's going on. So this is the OS part that we just covered. Now we are going to look at the purple one, meaning what's going on, what can you do if the performance is not really good and still the CPUs are really not used at all. So, for example, you have very low user time, very low system time, and still the response time is much higher than you would want them to be. Then you need to figure out what's preventing the threads from consuming more CPU, because if they weren't blocked, they would use all of it. So that could be, you have blocked threads, for example, you have synchronized blocks in your code that is too encompassing. You've put some locks in, and maybe too much pessimistic locking is going on, or simply you are waiting on something else, maybe the DB to return, or you're waiting for the network, the storage is overloaded, for example. And the tools that we use for that is either TDA, which is quite good at analyzing thread dumps, or YourKit, which is a profiler that will tell you a lot about the threading and all that stuff that's going on. And the good thing about YourKit is that you can do it on a continuous fashion. So instead of just getting 10 stacks, you can do it in second-by-second manner, and then it will do a nice graph and tell you if there is any blocked path, etc., etc. I would add that in 4.2 of Alfresco, we have a new tool that's coming in from the support guys that you can include in share, and it will give you some of this information. I mean, the ability to gather thread dumps, to tail the Alfresco log, to look at the CPU stats, the memory stats, and you can just have that directly in share, which is quite useful if you don't have access to the log immediately. So let's see an example of that problem with a customer example. They had built a custom front end, and Alfresco was used in the back end, and they were complaining about poor user performance. So we just came in and say, okay, let's profile the threads, because the CPU usage was very, very low. And this is basically what we saw. So all red, basically all the time. On the front end, Alfresco was doing pretty much nothing. So obviously, they had never profiled their own front end, and there was indeed a massive synchronization overhead. They had added basically some code that made it so only one user could be processed at the same time. So obviously, you can imagine the performance problem that you get for that. That is a view of what was happening in the back end once we fixed the first one. So still, Alfresco was not doing much of anything, because all yellow. Yellow is idle, waiting. So what the possible causes for this little solicitation of Alfresco? There could be something remnant from the front end. It could be contention. It could be waiting for external systems. So basically, We did the same thing, profiled the stacks, and found out that the database was actually really poorly performing. And what did we do to find this out? For example, I have a tool that's pretty useful for that. If you have, for example, as usual, you go in on site, for example, to a customer, or you don't necessarily have access to the DBA, he's not available, or whatever, or you want to have basically a DB point of, application server point of view of the performance of the DB, because sometimes the DBA will say, oh, it's perfect, it's working fine, no problem on my end, and still on the Alfresco side, you see very poor performance from the DB, so something's going on in the middle. And for that, I have a tool that's pretty useful. It's documented on the Alfresco wiki. Have anyone here used this before? Raise your hand if you did. 1, 2. All right. Well, Rich doesn't count. He's internal. So, all right. So basically, the idea of this is to have some way to profile easily the database from the application server side, and not caring at all about the DB itself. So you can do it from the application server very easily. It's just one jar, as we'll see later. And it's very minimal in dependencies, just one jar, one config file. And you get her some stats from P6Pi, which is a DB driver, Java DB driver. And then once you've gathered the stat, you can analyze it with a different tool I will mention. Just one note about the resolution, the time resolution. Currently, P6Pi only uses a millisecond resolution. So if you have nanosecond response time for your database, you might have some skew in the statistics, but it's still sort of relevant. But then, you know, if there is a network involved, it's most likely never going to be lower than a millisecond. So the idea is basically you can figure in just a very small file. This is 5 lines. You tell it what is your actual DB driver, basically, because it's a proxy driver. So the queries will go to the proxy and then to the actual DB driver. Basically, what do you want to log? Where do you want to log it? And then in Alfresco global properties, you would say, instead, this is my DB driver. So there's a very low overhead and very simple config, though if you have a lot of queries, it could be rapidly large. So you have to make sure that you have enough disk space to collect that. And you would analyze it with PT Query Digest, basically, which is a tool from the Percona toolkit suite that I've patched to add the ability to parse those logs from P6Pi. And the cool thing is that you can really get some very detailed statistics of the per query type and from the application server side without ever involving the DBA and just a few lines of config. So that's very useful because you can see exactly in terms of response times, number of calls, that particular queries was called, and how much of the percentage of overall does it represent in the total amount of queries that it processed. So that's very useful compared to just logging all the queries and try to do statistics afterwards. Because this way, he's going to be able to identify the same query with different values and then say, okay, this is the top query, this is where it comes from, and this is what I need to work on. So in this example, for example, we can see that the top query is a delete on unique context and a select on the lock. And so that's a bit strange that if you look at the percentage, 10% of the entire time spent in the database was a select about locking. So actually, we will talk about the resolution later. I just want to show that there is 2 views available. One is the sample query view that that will tell you all the different queries in a sample in an overview manner, and then you can get a detailed view per query type. So you would have even more statistical detail, as I was mentioning earlier, more than the average, the minimum, the maximum, the 95 percentile, standard deviation, the median, index of dispersion, variance to mean, all that stuff, and a quick way to find out basically in what range did the query perform. So basically you can see that most of the time it was in the 100 to in the 100 millisecond range and a little bit less for the others. So that's not so good for the DB. And you'll have also an example of the query on the bottom. So they could just give it to the DBA and say, give me the explain plan for that query. So that's pretty useful. And that works, obviously, independent of Alfresco. It's completely Java related. So in that example, we reviewed the code, and we found out that they were adding too much pessimistic logging in the custom code, which was resulting in a lot of pressure on the DB to handle those locks. So basically, we reviewed the app, moved to optimistic locking, and the problem was solved, both the front-end problem and the DB problem, and then the performance was acceptable according to their requirements. Just one note on the DB in general, sometimes we found out that the customers don't run the appropriate stat collection on the DB, so it's a different command, obviously, for Oracle and MySQL or Postgres, a different system, a different way of doing things, but make sure that the statistics are up to date. Otherwise, the query planner is just going to choose crappy plans, and you will end up with poor performing queries. Just a quick note about that tool. It's also able to parse out several other formats originally. One that is very useful and very cool, but works only for MySQL, is the ability to parse TCP dump. So basically, you could dump the traffic that comes into the DB with no configuration at all on either side, and then parse that out and have the same results that I showed earlier. So basically, you can compare what you see from the application side and what you see on the network side, on the DB side, and then compare what's the network overhead, for example. You can parse out also general log, the slow log. Sometimes you can parse out memcached results, and all sorts of things that are really, really useful. So I encourage you to go and look at the Percona toolkit and the wiki page I just mentioned. Okay, so we just touched about this a bit earlier. It's about the difference between current time millis and NanoTime. So basically, if you see a lot of, if in your application you call this too much, you'll end up with pressure in the kernel that will show up in the system column and VM star, because these are native calls. So every native call in the JVM is handled by the kernel. The precision of these calls are completely OS and kernel dependent. So the JVM cannot guarantee anything about actually, is it going to be 1 millisecond or is it going to be 1 nanosecond? It depends on the system. For example, on Linux, it's very good. On old Windows, it's really, really bad. So you can get, so the statistics that you will build just by using that will be probably not what you would expect. So that would be maybe precise, not be precise for one event, but if you process a very large amount of events, which is the goal of the tool we just provided earlier, then you would still have some statistic relevancy to that because you have processed a very large number of events. So let's move into the next problem area. For that case, you would, for example, see no real CPU usage. The CPU are not close to 100%. The CPU are, sorry, close to 100%. So what you want to do when you see high CPU usage in the first place, you want to turn on the garbage collection jog in the JVM. I highly recommend that you turn them on in production at all times, as we'll mention earlier. And then we'll move at the last area after that. So basically, with regard to the JVM, we could talk about this for an hour, but just a very short summary. As you may be aware, there are different memory zones in the JVM. The objects are allocated in the Eden region, which is a part of the young generation. The objects are moving around then between the survivor spaces, depending on your configuration, whether you are using this GC or that GC or what the size and all that stuff. And then once it's reached a certain number of copies, it will move over to the old generation during a GC. And then the object will accumulate in the brew region. And obviously, if they accumulate too much, too often, you're going to have problems. And you will see that very easily by turning on GC logging. GC logging is something that has very low overhead in production. It's only maybe 1 to 2% on top of the current GC overhead, so it's very minimal. The log files are rather small, so it can easily be stored on the local drives or something you want to store them on, no matter. And it yields really, really valuable information about the performance of the JVM over time. So this is really something that everyone should be using out of the box. So you probably want to use xloggc, which logs to a file, which is better than logging to the console in terms of performance. For example, I've put in some sample settings. You can say, this is where I want to log it, and I want the GC timestamp and the GC details as well, as we'll see a bit later. Just a quick note on JDK7, which we are now supporting as part of 4.2. You can have rolling log files, which is a long-standing bug in the JVM. You can use log file rotation. You can say if the logs reaches that size, then switch over to another log. You can tell it to have a certain number of log files and then roll over each one, and then the last one gets deleted, for example. So that's pretty useful. So if you are Chuck Norris, you can read the logs yourself. For example, you can see the purple one is the GC type. So you have par new, which is going on in the new generation. You have CMS, different types of CMS. The blue, pale blue in the top left is the timestamp since the VM start. The pause time is important. And you have also the size of the memory before, after, and the potential size of that generation, depending on your configuration. Obviously, if you have 1 million lines, it's not quite nice to have a tool to actually parse them out and give you graphs and give you stats. The tool of choice I use for that is HPJMeter, which has nothing to do with Apache JMeter. It's free. You can download it from the HP site, and it can give you many graphs, as we'll see later. For example, heap usage after GC over time in a graph per GC type, which is quite useful. The duration of the GC over time, does it stay stable? Does it increase? The creation rate of your application, meaning at what rate are you creating objects in the JVM depending on the load, for example, and many other statistics. That is quite useful. And we'll see an example of that with a customer sample just after. Just a quick note about JDK7. JDK7 changed the default log format. So basically, HPJMeter can't understand them by default, but you can adjust by using, for example, sed or whatever text replacing tool that you have, and just change the dots to the commas. And then HPJMeter will be able to find them to parse the log. Sometimes you have a bit of a mangled line because, for example, you have some concurrency issue in the JVM, for example. That's not really an issue because you might have 100,000 lines. So if you're missing one, the statistics are still relevant. What you can derive from GC log, you can derive an application to GC time ratio. Is your heap properly sized? Are your generations properly sized? As we just mentioned, you have the young generation, the old generation. You can decide of a proper sizing for each. Do you have, for example, too small young generation, meaning that objects are allocated in the old generation too much because there is not enough space to accommodate them in the young generation, for example? Tenuring threshold is very useful for a CMS GC because it will involve several copies in the young generation before it gets tenured. Tenuring is another term for old generation, so that could be useful to figure out too. And most useful is the heap usage after GC graph, which will tell you is there a memory leak or not, depending on the graph itself. We're going to see two examples of that. One example is an undersized heap, an obvious undersized heap. So I just started Alfresco and gave it 64 megabytes of heap. So obviously, that's not going to work. The purple ones are the emergency GC that the JVM triggers, which are different from the CMS and the parallel scavenge. Parallel scavenge is the other name for PARNU in the young generation. So obviously, here you see that you have a very high GC cost. And just by looking at the graph, you see that right from the start, right 10 seconds after the start, you are already in emergency mode. So definitely something's wrong with the Desizing. So this is just an introductory example. I just want to mention that you want to be careful about calling out a memory leak and analyze really the full GC to GC ratio, the heap sizing, the progress over time. Is there any object surviving too many collections compared to that usage? And this now we are going to see a real example, which is another customer case. So is there anyone here who can tell me what's going on there? Don't be shy. What's going on at 3 a.m. by default in Alfresco? All right, doesn't matter. So, the Lucene backup job. So this is a very interesting case that we had, I think, earlier this year, in January or something. That was pretty cool. And as you can see, that's a very long period of time running. So that's like 20 hours. So over the course of 20 hours, the application's fine for quite some time, for like 3 hours. That's the ramp. And then it starts to stabilize, which means the blue part is the young generation. So as I've given 2 gigs to the maximum heap, that means that and the new ratio is 2, that means that the young generation is 1/3 of the old generation. So there is 1.3 gigs left for the old generation. As you can see, there's a kind of a plateau as 1.3 gigs at some point about 2 or 3 hours. It starts to be filling out, and then at some point, around the 20,000 mark, there's a really huge problem. It's only GC, and the app basically frozen. So that's definitely the indication of a memory leak. So when you want to investigate, just before we move to that, you can see there is 2 important metrics that it shows in red. Basically, if you have more than a couple of percent, 3%, 5% maybe, depending on the context, you're fine. If you have more, then there is an issue, either with a leak, either with the configuration of a JVM, as the example before. So what you want to do if you want to investigate a memory leak, it's actually a bit complicated when you think of it, but it's quite simple when you've done it once or twice. Basically, you want to analyze, as we just did, the GC log and find out, that's probably a memory leak there. And you can use a lot of tools to do that. The important part is, a tip that you can have about is there a memory leak is that just looking at the generational count for all the objects in the JVM. This is going to be told by simple tools provided by the JDK or by your kit or by NetBeans Profiler. All of them will tell you that. And for example, if you have a very high number of generation, that means that this particular set of objects has survived in a very large number of generations, meaning it couldn't be collected. So there's several reasons for that. It could be legitimate. For example, it could be some cache that is not expiring. That seems reasonable. But it could also be objects that are not collected for some reason. And we see why afterwards. Once you've identified the candidates for a leak, you can have a profiler tell you what is the allocation stack trace from that object. So who allocated that object back from where it is, back to the GC route. So basically, that object was allocated by this one, who was allocated by this one, blah, blah, blah. And then you can find in the code exactly where that object was allocated and for what reason. And you can determine if it's normal or not. So basically for that, I usually use your kit. Something that is useful that you can turn on is also some options, and you can tell the JVM to automatically dump a heap dump if you're on a out of memory error. That can be useful, so you don't have to trigger it yourself manually. You can specify a path. So back to our example, it's quite interesting that the Lucene index backup jogs allows the GC to clear all the leak objects and go back to a normal situation. If we go back to the previous slide, as you can see, when the job runs, everything's fine. And that's pretty interesting. So what we did basically is inspect the generations, as we mentioned earlier. Is it quite clear? Not really. Can you read in the back or not really? It's all right. So basically, the object that is very strange is that we ended up with like 900 megabytes of exception objects. And that obviously is not right. So you go back into the code and see where those objects were allocated, and you're looking for domain classes. Domain classes is mainly doesn't start with Java, because the JVM will never leak unless you tell it to leak. Otherwise, there's a huge problem for them. So you want to look for domain class, meaning your code or your product code. And in this case, we had some debug left in. That was pretty interesting. In that code, when you just correlate what your kit tells you and the code itself. So instead of a decrement, we had an add. So it's probably just a copy and paste. You can never find it if you just look at the code. That's impossible. But if you use the right tools at the right time, then your kit will tell you that exactly what the problem is. So basically, we fixed that problem, and then we reran the test, and we had this instead. And as you can see, it's all stable, it's all nice, no problem. So that's one of the areas. We could talk about a lot more. I'm just trying to cover different sections in that presentation. We have now to cover the last part of the presentation. The last part is if there's no problem with the GC, the CPUs are still quite high, and system CPU is not really used, then you want to look at the actual application itself, algorithms or CPU burning methods or whatever. And for that, you're going to use, as we just mentioned, if it's like you have high CPU, low system CPU, no problem with the JVM, then you would do execution profiling. Execution profiling is done with the VM agent, most likely. It could be your kit, it could be NetBeans, it could be whatever. I just happen to use your kit most. And with that, you can tell it to identify. It has quite a significant overhead, though. So it's best if you can reproduce the problem in a test environment rather than doing this in production. Because this, you can set it to a sampling mode, which is going to be taking samples at regular intervals, but it's less precise than if you turn on tracing. And tracing will have a very high overhead. So basically, when you do, I don't have an example of that because we don't have the time, but basically, you just find the method that are consuming the most CPU and fix them or change them or re-architect the solution so that it doesn't use that much CPU. We have a couple of minutes left, so I'm going to just do a bonus slide, and then we'll move into question and answers. There is a thing that is quite useful is that sometimes the support people or we go on site and we see customers or partners with a giant amount of options for the JVM. And that's probably 99% of the time completely useless. So you can drop all the flags and just start with a very minimal amount of flags. Obviously, you want to size them properly. So the very minimum is giving it a decent amount of memory, depending on what you want, depending on the use case. But the rest of it, there's not much tuning to do, maybe choosing a GC, etc. And what is interesting is that even if you don't have all the JVM source code for a particular release, you can very easily extract out all the flags and their default values for the JVM that you have. There's a tool provided with the JDK that's called JInfo. And basically, if you extract out all the flags that are provided in the JVM and then loop on it, it will tell you exactly all the default values for all the flags in the JVM. So that's pretty useful if you have, for example, the flag, thanks. If you have, for example, put a flag in your config that's actually the default, well, you don't need it. And obviously, you don't need to know all the flags in the JVM because there are close to 800 flags in the JDK7, so that's obviously not useful to put them all right. Do you have any questions? Maybe you need to wait for the mic. Yeah, she's going to bring the mic.
When we were struggling with Alfresco and enterprise version on memory, we tried swapping out for a different garbage collector.
All right.
Is that a good way to do this? And on what kind of garbage collector do you advise for Alfresco? Or?
Well, the thing is that it's quite difficult to recommend one for every use case. So the thing you do not want to do is copy and paste options that you found online or whatever. What you want to do is, as I mentioned, is get a GC log, find out if the GC overhead is too high for what you have, and then investigate, is there a memory leak? Is there a problem with my VM config? Obviously, you have different types of GC. Some of them are working in the new generation. Some of them are working in the old generation. Some of them are working in parallel. Some of them can yield.
It was exactly the parallel one which we switched or not, and
CMS?
we didn't. Yeah.
So
it was a mark and sweep we could set in
so there's
parallel.
a lot of possibilities to configure it. You can configure it to, if you have, for example, a low number of cores on your machine, you might want to use the incremental mode, because that will actually yield back to the application, and it will only work incrementally. So we'll try to avoid long pauses because you have a low number of cores. But if you have several cores on your machine that you can use for GC as well as serving the application, then you might want not use the incremental mode. But that's only a general recommendation, because the only source of truth is the GC log. And analyze it depending on the context, on the load, on the server, on the hardware, all that stuff. And if you find a percentage that is below 5%, nothing to change. The problem is elsewhere. Any other question? Yeah. One in the back.
One thing I found useful is trying to work out the number of Tomcat threads and then match that up with the number of database threads and make sure I've got enough database connections.
Yeah.
It's not something I've seen a lot on the wiki about. Is that just because I'm being awkward, or is it something that more people need to know about?
In general, I would say the thing is that obviously you want to dimension the Tomcat thread pool realistically compared to the DB, all that stuff, but all of that you can find out if you do thread dumps. If you do thread dumps and if you use, for example, your kit in thread profiling mode and you see red blocks, it will tell you, well, I was waiting for a DB connection of the pool and I didn't get one. So basically this is a precise way of telling, is my connection pool correctly sized? Is my Tomcat thread pool correctly sized? Obviously you also want to propagate that upwards in the chain if you have an Apache in front or HA proxy, so that it propagates well from the front end to Tomcat to the DB. But I wouldn't know if there is a really specific recommendation to put that number equal that number. I guess it depends on the use case, because some of them might not use a DB as frequently as other use cases. So kind of depends. Rich.
I think there's a number in the zero-day config, and if I remember correctly, they actually say 2 times the number of worker threads plus 75 or something like that. So they're even a little bit more conservative.
Yeah, rule of thumb, yeah. There's one in here.
You've mentioned that one of the first things you look at is to see where the cycles get spent, in the user or in the system part. I was just curious because I've never seen, I've never had a case where actually the system part was the large one. Do you have an example?
It's never going to be huge unless you have a massive problem. For example, I remember a case a couple of years ago where they were doing a benchmark on machines provided by a certain provider, and these guys were billed yearly on a number of processing units that they have. So since it was the end of the year, they almost had nothing left, and they were like benchmarking 200 concurrent users on 2 cores or something like that. In that case, the system was massive because the CPU was completely overloaded with requests. You know, is the what do we call context switching, which means when a thread has to be ejected forcibly from the CPU to put one in place, and it was spending its time doing that. So that could be an example. If you have, for example, very slow storage or a buggy storage driver, you would see system quite high. But it's true that it will generally not be very, very high. But still, if it's 15, you might want to look at the dB, the storage, whatever, because it's not supposed to be that much. It's always supposed to be low. Lowest is good. Low is good. Well, in any case, I do recommend that you stick around here for Derek's presentation and Michael's. They're going to talk about the benchmark framework internally. I think it's going to complement this quite nicely. So do stick around, or come find me in the halls and whatever, and we can talk about whatever you want. Thanks.